Of course. Okay, can you see the PowerPoint?
Yes, we can.
Fantastic, great. All right. Hi, everybody. I am Sasha Crotty. I am the Revit product manager responsible for Revit platform. So that's multidisciplinary functionality and the cloud services that we're building out with Revit technology. Presenting together with me today is Rahul Bhobe, who is one of the engineers on the design automation for Revit team. And the thing we're going to be talking about is introducing you to design automation. We'll start with a little bit of introductions in terms of what the service is, and then we'll dive into a few technical details as we go along. All right, here we go. So one thing I do have to remind everybody about is there are going to be a few future-looking statements. So please don't make purchasing decisions based on what you see. What we can only say is these are the best of our intents of what you'll see in the future. They may or may not happen. So with that, we'll cover on the agenda today, we'll cover what is design automation. We'll cover a few examples and workflows and videos that you can see. We'll show you a glimpse at the roadmap, and we'll talk a little bit about how you get started with design automation. And we'll pause a little bit for a Q&A. So what is design automation for Revit? So Andrew talked at AU this year and a previous year about this idea that we can do better than we are doing today. And a huge part of that is automation and what we can actually do to make our customers more successful by making their processes more efficient. And that's where Forge comes in. Certainly we can automate the end user experience, but we also want to make sure that we're making it possible to create applications that automate a lot of workflows. So that's where kind of the details of Forge come in. And one of the reasons I show this slide is not so much because I want you to look at every single piece on here and what we're thinking about, but more because this is something that not only do we expect third-party applications to build on, but this is something that Autodesk is building on. So Forge is here to stay because it's something that we build our own applications on. And what are the different pieces of Forge? Well, one of the pieces is the data management API, and this is basically where you can store and access your data on BIM 360 if you want, for example, or other parts of the Autodesk data storage ecosystem. There's the webhooks API, which calls you back when there are changes. There's reality capture to kind of understand what's happening in the built environment and actually process point clouds directly in Forge. There's the BIM 360 API, which connects you to BIM 360 capabilities and allows you to automate a lot of processes in the BIM 360 ecosystem. There's the model derivative API and the viewer. And this is kind of our big step into being able to see models from other products and be able to view them in a web environment, to integrate that into your own applications if you want. And make that really easy for you. So certainly you don't have to build your own viewer to work with Autodesk technologies. And last but not least, this is really where a design automation API comes in, because this is the piece that allows you to start truly working with design models from all of our hero products. So design automation is the thing that allows you to modify them, to read them, to really do completely custom things with them that go much beyond viewing and looking at the data. So what is it? Design automation is really batch processing for models that come out of Autodesk's product engines. So at this moment, we've launched with AutoCAD, Inventor, Revit, and 3ds Max support. And what you can do is you can take inputs and generate either output models of those versions, or even take Revit files, for example, and output and modify them if you want. So what does that mean for Revit specifically, since we're talking about Revit today? For Revit, it's really essentially headless Revit in the cloud. So the same familiar Revit API that you've seen on the desktop, now available in cloud-based form. So what we've done is we removed the UI and we made it available as a service. You can go ahead and batch process jobs as much as you want and take advantage of the same APIs, but now in a cloud-based service. That means you can build cloud-native applications that don't actually have to touch the Revit desktop anymore. So what are the few of the details of how the service works? Well, first of all, I mentioned it's batch processing. That means that it's something where you send a job and you execute that job, and then at the end you get outputs. But you can do it, you can do it in batch, you can do a bunch of jobs in parallel. It certainly allows you to automate tedious tasks that you may have to have done on a regular basis, possibly on the desktop, causing people to wait and sit there waiting for the job to complete. The really cool and powerful thing, as opposed to you trying to build something like this yourself, is that it actually supports multiple versions of Revit. And the really important thing about that is that you don't have to maintain any of those versions. We do that for you. We always give you the latest and greatest. All you have to do is choose which version you actually want to run with. And then the other really important thing is there is no license to Revit needed. So we actually charge you for design automation directly, but that means you don't have to have an install somewhere on your, running and paying for that those licensing fees. Other really important details. First of all, this is Revit's database layer only. So there is no Revit UI API.dll. So if you have applications that are using that DLL, that's not going to be available to you. The reason, simply put, is that there is no UI as part of the service. It's just the data layer. Another restriction that design automation has is that there is no access to the network. And that means that when your job is processing, you can't kind of reach out and grab anything. There's a little bit of an exception to that. I'll talk about it a little bit later. But overall, you can't really access things in the network. You can't like dynamically connect to a database or dynamically have user input. And that part, the user input part, is the thing that gets us to no interactive sessions. This is not something where you have a Revit running in the background where you can build your own new UI. This is a batch processing engine. So it's not something that where you're constantly running and communicating. What you have to do is gather all your inputs up front, process the job, and then deal with the outputs. It's still possible to have kind of a UI-based experience. It just can't be live where you're actively working with a Revit session. And this is really, I highlight here, these are the connection points. The inputs and the outputs are really the connection points to the internet. Everything else is secured. It is in a sandboxed environment. So it's something to think about when you're designing your application. So how does it work? First, you have a user or an application at the end of the day that makes data available in the cloud. And it is really important. We do have to have, the data does have to be in the cloud because it can't be on a user's network, right? Because customers don't really want to give access to their network to Autodesk for obvious reasons, which means that data has to be in the cloud. That said, we don't really care where in the cloud it is. So kind of pick your poison, I guess. And so once that data is available in the cloud, the next step is to send links to that data and access permissions to design automation. And access permissions in our case essentially mean assigned URL, where you're saying, we have permission to access this data for a temporary period of time. What the design automation then does is it downloads those inputs via the links that were sent. And the next step is, now that we have all the input information, we can go ahead and run your add-in. This is entirely your add-in. We don't know what code you're running. You can write whatever code you want as long as you're using the Revit API. And when the job is done, the results are uploaded back to a location or to a different location that, again, you specify. The key thing here is that we don't actually store your data after the job is done. So we throw it away. So this is not something where we are storing your data. It is entirely within your control where the data starts and where that data ends up. Once the job is done, we no longer have your data. So what are the different workflows that you can do with design automation? So again, you have an application that's sending data to Forge. In terms of Revit, what you can do is you can create Revit files. So if you had a bunch of configurator and you wanted to create Revit files, you can do that. You can also take existing Revit files and extract information for them for charts, visualizations, anything you can imagine. And last but not least, you can also modify Revit models, taking a model and making changes to it and putting it back in the same place. So we talked about design automation for a few years, so I thought it's worth mentioning what are the changes that have happened since the previous year. One of the big changes is that we've added support for Revit 2020, and we plan to continue doing this for future versions. We'll keep, as we issue new versions of Revit, we'll add those new versions. So again, very little effort for you to update from one version to another. You just have to make sure that you're specifying the right engine. The next thing, we've enabled virtual printer drivers. So there we had a lot of people who wanted to take advantage of having a virtual printer. So that was something that we added to the capability of the service. We've also added IFC support. That includes export open and linking of IFCs. That was a big request from some of our beta users. We've also added support for local debugging, so making it easier for you to emulate that cloud environment directly on the Revit desktop. So you can get a better sense of whether your application will run. This is particularly useful if you have previously had a UI-based application and you want to make sure things like different UI references are out. You can go ahead and start to emulate some of that. Additionally, we've actually added the ability to override the default timeout limit. I believe the current limit is 2 hours. If you want to specify something different than that, you can go ahead and do that. Certainly, these things are configurable at the end of the day by us and for different applications. So if you ever run into limits, just let us know. Let's have a conversation about it and see what we can change. We've also added support for on-demand inputs. I mentioned a little bit earlier that I talk about the fact that there is an exception to being able to get data during the middle of your call. During the middle of the execution of your add-in. You can do that using on-demand inputs. So you can basically say, these are the inputs what I want when I demand them during execution of my add-in. We've also added a number of different samples to help you get up and running. We realize that this is the fastest way for you to do that, so it's definitely an important thing for us to do. So enhancements to samples and enhancements to documentation. And then the other big thing is we spent a lot of time improving things in the back end to make sure that the service is scalable, available, and ready for prime time, which we truly are at this point. And the reason I say that is because we actually officially launched on October 28th, which was a very exciting day because this is many, many years in the making. And the way that we are charging for the service is it continues to be 4 cloud credits per hour per processing hour for AutoCAD. And for Revit, it is 6 cloud credits per processing hour. You can find out more on the Forge pricing page. In case you're wondering how we charge, because I had to look this up recently, basically what we do is we count to the second how long your job runs, and then we add that up, and once you hit an hour, we go ahead and charge you. So this kind of adds up on your account until you actually reach an hour, and at which point we charge for that for those transactions. So let's dive a little bit into different workflows, a little bit of details and examples to hopefully get you excited and understand better what are the possibilities of what you can do with the service. I mentioned that one of the things you can do is create Revit models, and that includes RVTs or RFAs. So for example, one thing you could do with Create is create families dynamically based on a configurator. Or you can create Revit models based on layout apps. So say you know how to lay out all the furniture or a kitchen or something like that, you can go ahead and do that and generate a Revit model from that. One of my favorite things that I'd love to see someday is the idea of a stair layout generator. And the reason that that's really potentially really powerful is stairs are really, really complicated. So if we can get people to create something, a much better UI to actually generate stairs and just be able to plop that inside of an RVT, that is a really powerful thing to do. Another idea is something like converting a third-party format to RVT or RFA. And as long as you know how to read that third-party format, you can do whatever and then make sure that you just go ahead and create an RVT. It's also possible to do things like connections between Inventor and Revit, because as I mentioned, Design Automation API also supports Inventor. So if you wanted to read from an Inventor model, create an intermediate format, and then go ahead and create an RVT, you can actually go ahead and do that. And then the last one is really to auto-generate documentation. We had one partner who was looking at many years of an experience of generating documentation in AutoCAD, and they were looking to transition that and say, take a Revit model and output documentation to 90% of what a user would have to do. So here is an example from Blackboard Industries on what they've put together. And so what they have is a web-based generator that allows them to put together a bunch of different options. And at the end of the day, the reason that this is really powerful is this puts those options into a BIM 360 project where they can, excuse me, where they can then derive all the documentation. And what that means is that people who were previously never able to be part of the full process, like a salesperson, can now basically generate full specs for a shed. So in this case, you start to see that they're working in parallel, making different configuration changes to the shed. And the really powerful thing is, again, because they have control of the rules and all the specifications, this is detailed to a level of detail that this can actually be manufactured and assembled directly on site. So they've taken something that previously would have taken hours and days and many, many different people and put this tool in the hands of someone like a manager or salesperson. And you can see that as they make changes, those changes propagate to BIM 360, and you can start to really get all the benefits of this ecosystem and make sure that those updates are happening in the background. Another example is from Perkins and Will, who've created a web-based massing studies for non-Revit personas. So people who are willing to explore the site. But the really powerful thing is that, there you go. The really powerful thing about this tool is this, again, is a connection between two different personas. So you have somebody who is an early stage designer who is exploring, looking at a specific location on the globe and saying, here are the different options of what I can do. They can go ahead and place that and start to explore that location and assign things and assign spaces that are part of the, sorry, this is going quite slowly, apologize. Assign spaces to their model and understand what it is that, how they can actually lay out that space and how they can lay out that building. See, now they're exploring the site. Apologize, this seems to be even be playing slowly on my, oh, I guess this video is going to cut out. Okay, well, I apologize for that. Hopefully we'll, I'll make sure to edit the recording to improve that. But anyway, so what they can do is they can actually generate all the different levels and assign the spaces to those. And once that is done, once that persona is done, they can hand it over to the design team to actually get all the more detailed information. And hand it over in a Revit model form to the team that can take that design forward. So other opportunities here are for extract. So how do you take information from an existing Revit model and extract information for it for downstream uses? So certainly the most typical case we see is doing a custom extraction, whether that's to Excel or a private database. It's possible to go ahead and pull information from Revit and then put it in a custom form that starts to make sense for either other personas or for people to understand what's happening in their model. One other opportunity is an automated nightly extraction to something like IFC or DWG. You can go ahead and automate a lot of those tasks with design automation. You can do QE, QC, and code checks. If you know how to interpret a model, you can basically, on a regular basis, pull that model, do those checks and comparisons, and validate that what you actually got is what you expected, or that there's not missing data from the model. It's also possible to do things like clash detection. You can pull data from the Revit model and then compare it against other models, as long as you know how to write the code for clash detection. And ultimately, we hear a lot where people want to simplify their models and reduce some information before they exchange with the consultants because they don't feel comfortable sharing the entirety of the Revit model. It's certainly possible to take a Revit model, remove views or remove family information, things like that, before handing it over to that third party. So the first example I have is an integration with SkyCiv and Revit. And what SkyCiv does is it does structural analysis software. Apologize. Okay. Let me go ahead and do that. There we go. All right. So what SkyCiv does is it's structural engineering software in the cloud. So what you can do is you can take a Revit model and import it to SkyCiv, or take a SkyCiv model and export it into Revit. And this really starts to enable the round trip where you can actually go back and forth. And at the end of the day, you can do this inside of Revit, but you can also do it dynamically in the cloud. So here we're taking a SkyCiv model that was exported, and you can start to see that it actually is visible again in Revit. And now we can go to SkyCiv and bring that model back. And now that was an example of actually not having the Revit desktop involved at all, and you can actually start to import models from Revit to SkyCiv. And the bidirectionality of that is really powerful. But the really cool thing is that, again, you can do this in a browser without ever having to touch a Revit desktop. Another example of using design automation for extraction comes from Mustafa Saladin and Imad Hana. They put together this example of connecting design to manufacturing to visualization with collaborative lighting. So basically you have a large Revit model, and design automation is used to extract part of that Revit model and send it to 3ds Max. And this means that they have a complete set of information available to actually generate the really high-end visualizations. But again, because they have the Revit data in the background, they can actually go ahead and connect design personas and manufacturing, because they can take it all the way from one persona to another persona. So here you can start to see they're using the web viewer to display a shop and all the information in it. And they're able to pull that from a Revit model. And once they are able to pull that information, they extract just the information that they need and they send to 3ds Max and they render it. And you can start to see that here is the rendered result. So we've started to take a Revit model and take it to connect it to 3ds Max, and so we're using multiple images. And again, all this information is quite detailed enough that they can actually start to connect to manufacturing personas as well. And another example that we have is Imagineit. So Imagineit is also using design automation to extract information from Revit models. And the really powerful thing is this is the same capability that Imagineit has always had on local servers, but now their capacity can be expanded to the cloud. So you can start to see that you can have tasks that, and what Clarity does is it allows the automation of tasks and kind of batch processing, and typically they've done it on a local environment. So you can actually have different tasks that be created, and you can specify now that the destination or the processing location of those tasks is in the cloud. So you can start to automate all the things that you're able to do locally, you can now do without actually having many servers set up in an office. So a great example of actually expanding capacity using design automation. In terms of ideas for modifying data, there are kind of quite a few things you can start to do. Certainly executing nightly model tasks and models. So saying every night I want to go and fix these kind of mistakes that I know people make, or I want to make sure that all my views are named correctly, and I want to make update all my view naming. Other opportunities are batch updates and upgrades. It's certainly very easy to upgrade hundreds or even thousands of Revit families or models overnight. We see quite a bit of usage in that direction from some of our partners. Automatically replacing out-of-date content. So if you know how to track whether content is out of date or not out of date, it's possible to take a model overnight, update it to the latest content, save it in the morning when people come back. It's actually the same content, or sorry, the updated content. The one limitation I do have to note here in terms of modify is that there is no way currently to directly modify a central model, unfortunately, because as I mentioned before, we don't have access to customers' networks, which means that we can't access their either Revit server or local work shared cloud models. Local work shared models. The only kind of opportunity of something that we can do would be to connect to Revit cloud work sharing models that are part of BIM 360 design. Unfortunately, currently that is not a possibility. But we'll talk about a little roadmap going forward. So what are examples of modifying models? So the first example I have, it comes from Design Automation Systems, who've created a rules engine that can automatically generate wall framing based on an architectural model. So they take an architectural model, they apply the rules engine, and from that, they can generate a Revit model, they can generate an Inventor model, or they can even go directly to CNC in manufacturing it with something like a Howick machine. So in this case, what this is showing is taking a Revit model and sending it to a cloud-based environment. So now you can start to see, here's that same model. You can see it in the Forge viewer. And what this automation is able to do is take one of the levels of that and actually show it, generate the framing for that one level in that one room. So now you've got a complete framing for that. You can start to see in the viewer, again, because anything that's RVT based, you can extract to a viewer. And then because it's actually an RVT, you can go ahead and download it and link it into the original model that you had. That means that now you see that same model fully framed in Revit. So you can understand the impact of design decisions directly here. And the powerful thing is now, because we also have design automation for Inventor, you can actually go ahead and take that same model and generate a fully specified Inventor manufacturable model. with full details. So you can start to see where all the connection points are, where all the holes are drilled. So this thing can actually be sent directly to a machine that generates it, and this can actually be assembled off-site. Another example of the modify workflow is import and export of Excel. So this is a bidirectional connection between Revit data and Excel. So what we'll do is first we'll start in the Revit viewer, and then we'll take a look at the parameters on this model. And in this case, we're looking at doors. And you can start to see the properties on it and the values of those properties. They're empty. All right, and then what we're going to do is we're going to go ahead and download a spreadsheet, an Excel spreadsheet based on that data. Now you can go ahead and open that spreadsheet and make modifications to it, to the parameters that are available for the doors. Add comments. And then the really cool thing, this is where the modify workflow comes in, is now you can go ahead and upload that same spreadsheet back to the cloud. And what it'll do is Design Automation will take that spreadsheet and will actually apply those parameters back to the Revit model. And see, now we've got a new version. And now we can look and see whether those parameters have actually been modified. And you can see that those changes that we just made have been applied to the model. Now, the really, really cool thing about this example is that is actually a sample. So you can go ahead and use that as a starting point if that's a workflow that you're interested in. So that's something that comes from Autodesk, and we make that available for you to start with. And then there's also, I mentioned examples before, there's a bunch more samples that we've put together. One of them was put together by Rahul, who will be talking in a moment about other things that you can do with Design Automation. So check out the samples if you want to get started, because that's one of the best ways to get up and running. So where are we with the roadmap? There are a number of different enhancements that we've heard. This was something that we actually polled people about at our AU class. So here's kind of the roadmap as we see it today. The first thing we want to do is we want to fix that gap that I mentioned about not being able to modify central models. So the first thing we want to do is we want to open a live Revit Cloud Work Shared model. So not a published version, but an actual live Cloud Work Shared model. Next thing we want to do is be able to sync changes back to that central model. So essentially Design Automation behaves like another user of a cloud model. And that will really truly open up that modify workflow to all the possibilities of what you can do with Design Automation. The next thing on the roadmap after that is the ability to run a Dynamo script. We've heard from quite a few people who either test trial new add-ins through Dynamo scripts first, or people who just want to write a Dynamo script. We want to open up that capability to be able to execute that and use that as part of Design Automation. We also will be going for SOC 2 compliance for Design Automation. That's actually a requirement in order for us to support Revit cloud models. And we know that it's important to make sure that we have the right protocols in place to keep your data safe. And then last but not least on our roadmap is the ability to create PDFs. We do want to be able to generate those. We're looking at more PDF capability with Revit, so certainly something we'd want to add to Design Automation as well. With that, I am going to hand it over to Rahul to talk about how do you get started.
Hey, can you hear me?
Yes, we can.
Okay. So I should take control, Sasha?
You can just go ahead and tell me and I'll advance the slides, probably easiest.
Okay. So yeah, you can move to the next slide, I guess. I believe this was your slide. We can move to the next one. Yeah, so I'm going to do a quick recap for what Sasha already showed in the previous slides. If we can move to the next one. So what is design automation? Design automation is a service that lets you run your design, lets you run your automation on your design files. You provide your source code, you provide your code, DLL, and you provide your data to design automation. Click this. Yep. And design automation runs your code on your data and generates input files, generate output files. Click. Okay, quickly, this slide you've already seen in Sasha's. You make your data available in the cloud, could be anywhere. We recommend Forge Data Services. Click, send your links, send your job to design automation with links to your data, typically assigned URL. We will download the links, run your Revit add-in on the input files, and then when the job completes, we would upload the links to upload your data to the links you provided. So in the process, we do not store anything. Just one thing I want to bring up is my future slides are going to focus mainly on how to get your data in and out of design automation. So the 3 arrows that point towards Forge and out of it. Okay. Next slide. Okay, top level overview of the API endpoints we have. We have these are the 4 main APIs. There are other APIs. You can call them objects if you wish, entities, work items, activities, app bundles, and engines, and they relate to each other from top-down structure. That is, work item refers an activity, refers an app bundle, refers an engine. Click. So if you call activities a function definition, work item would be a function call. It's the actual job object. So which is why activities have parameters, whereas the functions, the work item has the arguments, similar to function calls and function definitions. Click. Okay. So your app bundle is nothing but the add-in code that you write, the DLL, similar to your desktop add-in, just that it needs to be a design automation compatible app bundle. An engine is nothing but the actual Revit executable that runs. It's the headless version of Revit, and we provide 3 different versions. That is 2008, Revit 2018, 19, and 2020. Click. So that was just a quick overview. Okay, I'm now going to show what we have. So anyone who's just getting started should use, I recommend using Postman Collections. So if for anyone who doesn't know what Postman is basically an awesome third-party tool that allows you to configure and make API calls. We configured our APIs so you could make those calls. And in this video, upcoming video, I'll use a simple to understand pre-built Revit add-in and run a design automation job on it. The add-in does nothing but deletes all walls from an input file. Sasha, if you can go ahead and play the video next. Start. Okay, so Postman Collections are linked inside our documentation page, design automation documentation page. Once you get to the repo, you can either clone it or download it. As I mentioned earlier, it contains a pre-built Revit add-in that does nothing but delete walls from an input file. It also contains an input file. In case you don't have one handy, you could use this one. So let's just examine what's in the input file. It has a bunch of walls and some furniture. Okay, now from the repository, we will load the Postman collections themselves and also load some environmental variables. Once you load the environmental variables, you provide some values, user-specific values to the environmental variables. These are unique to a user. And now that's it. This is all ready to start. Is this paused?
No,
I
still
think
playing.
so.
Looks like the video got paused.
Yeah, we can share the video right at the end with all the presenters or the attendees.
Ah, okay. Oh, okay. It did continue. Okay. So, so if you follow, once this is done, it walks you through a step-by-step creation of an activity, uploading an app bundle, creating an activity, an alias, preparing a cloud storage for your input and output files, and then finally run a work item. You can also check the status for a work item. Once it succeeds, you can get the logs from the design automation and also download the output file. So this walks you through a typical workflow of running a job on design automation with a simple to understand add-in. So this is this was the input file, and now we are loading the output file. We see that the walls are deleted from the input files. Okay, so I guess we can move to the next slide. Okay, so the reason why, so for anyone who's just getting started on design automation, I really recommend this Postman samples. We already got good feedback from a lot of customers who've already used it. We've also fine-tuned our Postman samples to based on the feedback that has been provided by customers, beta customers that we worked with. Why is this a good start? Well, it starts from Sasha, click, I guess. Sorry, it starts from scratch. If you have never run a design automation job, you've never run a Forge job, or even if you don't have a Forge app, this still works. It takes less than 10 minutes total to for any new user to go through all these steps, and it also has a simple to understand add-in which only deletes walls from an input file. It also, and click, it's input and output files are also very simple to understand. Input files have files, walls, output files do not have walls. It's just left with furniture. Finally, once you're done with this, you have successfully run your first design automation job. And you did that, and I want to stress that you did all this without having written a single line of code. You just so you know what goes on, what is needed in the background to be able to run a design automation job. So if you can move to the next slide. Okay, this will get technical. I will show some code now. I'm going to use delete walls as an example to decode its activity definition. Next slide. There are a lot of animations on this, Sasha. So, okay. So now the command line field is the one that, if you can back up a bit, sorry. Okay. The command line field is the command that is run on the worker machine when the job runs. We start with Revit core console.exe. That's the first click. Okay. First, we have Revit core console.exe. For Revit, this is the only executable available out of box for you to run. I believe in Inventor and AutoCAD have more than one executables that you could run, but in Revit, this part of the syntax will always remain the same. Click. I guess click again. Oh yeah, that one. So it takes the core console.exe takes an input argument, optional input argument, which is the path to the. So if this is not specified, If this is skipped, we do not open the Revit file for you, which means you have to open it yourself or create a new Revit document, depending on your workflow. In this case, it is specified, so it is opened. It opens the Revit file, input Revit file that you provide in when you post the work item. Click again, I guess twice. Click twice. So this syntax, the next one, this remains same for all your app bundles. All your activity definitions. Just insert the name of the app bundle here in this case, it's a delete walls bundle. So whatever the name of your app bundle is, you'll have to insert that. Click. Your activity refers an app bundle with its fully qualified ID. In this, what is a fully qualified ID is nickname dot app bundle name plus your alias. Please read documentations about all this. I have not covered this in this talk today. So you can read about what is a fully qualified ID and unqualified ID and when to use both of these. And like in this example, both on the slide, both got used here. So if you can move to the next slide, Sasha. I want to talk about parameters. So parameter definitions, there are two used here. One is RVT file and the other is result. And the verb next. So the verb get indicates that it is an input parameter, whereas the verb put indicates it's an output parameter. So when the job runs, the URL associated with the input argument is called before the job execution. So we get the data before the job executes. And once the job concludes, we call the URL associated with the output argument. We put the data. Next. The local name field here suggests which file to upload from the current working folder to the output URL you provided. This field works similarly for input and output argument both. In this example, we have used it only for the output argument. So you got to make sure that you save the file as result.rvt in this case. Next, okay, required equal to true suggests that these arguments are actually whenever you post a work item, these arguments need to be specified. If you want to skip an argument, the activity definition should have required equal to false, sort of like how you make a function call with default arguments when you can define a default argument function with a default function definition with the default argument. The only difference between this and design automation is that you cannot specify a default value for the argument. Next slide. Just moves on to the next slide. Okay, I'm going to use another simple demo. It's a demo purpose only. This is something that we worked with Atkins, Mustafa, I believe he also showed this demo in his AU class from last year. If you look up his name from the AU profile, you might have his recording with more details about these demos and several other demos that he worked on. Okay, next slide. So this is again a video. Okay, this is about content creation. First, Mustafa creates and maintains a catalog of families. Then a user from a web browser. So this is a web browser. A user drags the family thumbnails into a viewer to place the family instances. Once done, he sends this data to design automation. Behind the scenes, design automation generates a Revit file that can be downloaded. And then that's it. So it's very simple to understand. Demo. Let's look at how it, I guess you replayed, yep. Okay, let's look at how, okay. So you started off from a browser, sent data to design automation, and in turn, it returns you a Revit file back. Let's see how you can go about setting something like this up. Okay, so the task here is to pass this placement information from the viewer, that is your browser, into design automation and run your design automation job. So to start with, you specify an activity parameter with a hard-coded local name, family info.json. So this sets up a contract between you and design automation, which essentially says that you are going to send data and design automation will save it as family info.json into the current working folder. Next. So when you have your data, that is, user has placed those information, that is chairs or desk or whatever, you can now call your work item, the actual job object, and you can embed that data right inside your work item payload. Here's an example of a chair and desk placed on level 1. So this data could be anything. Design automation is agnostic of what data you send. As long as it's a valid JSON, it's good enough for design automation. It'll copy this data into the file name you specified in the like I mentioned in the previous slide, previous animation. Next. Okay, now you have the data saved in your in the current working folder. Design automation kicks up your job. Your app bundle code, which you already provided, knows exactly what file to read from, which is again what you have provided. Once you read that data, you can generate the Revit file based on that. So this, okay, next slide. So this, yeah, so these 3 simple steps allow you to transfer data from the browser to design automation to generate a Revit file and run your code and generate this Revit file. Okay, I have covered in my AU class from this year, about 15 days ago at Vegas, I have covered more problems that we solved, interesting problems that we solved while doing this demo. Please look up I think Sasha has my details about my slides, about my class in the future slides, in the slides that will come up now soon. Okay, this is another demo that I worked with for the AU class that I just mentioned right now. This is again working with a customer, with a private beta customer, Blackboard Industries. Thiago came up with this idea. So what this does is it uses OpenStreetMaps API. It's an open source API where you can query, given a bounding box, latitude and longitude bounding box, you can send that information to OpenStreetMap API, and it will return you some building information, that is building coordinates, their height, and other things. Once we get that information, we generate a Revit file with building data using direct shapes. So that picture there behind is generated from I believe it's Manhattan, downtown Manhattan. We are now going to start the video soon. Okay, so pretty much self-explanatory, I guess. A user zooms to a map location, selects a map, selects a bounding box, sends this information to to OSM API. It streams the data directly to design automation. Design automation generates a Revit file. And one more time, a different city, zoom to a location in a map, select a bounding box, send the bounding box to OSM API, stream the results directly to design automation, and get back the Revit file with buildings generated. Again, a simple to understand demo purpose only video. And okay, so let's look at what happens behind the scene. Just to recap, we selected a bounding box on a map, sent it to design automation, and design automation generated buildings. What would you need to get something like this done? You set up an activity parameter. Again, you specify a local name for it, hard-coded local name. So this again sets up a contract between you and Design Automation. You will send data and Design Automation will save it as osmdata.xml. Next. Okay, when you post the work item, in it, you can now directly specify the OSM URL. Now here's a classic example of you don't have the data, we don't have the data, Design Automation doesn't have the data, Forge doesn't have the data, data is with the third party. As long as that URL, there is a download URL, Design Automation calls that URL and saves that data to the file name you have specified. In this case, it's osmdata.xml. Next. Okay, once your app bundle, your add-in code runs, you know where the data is, you can read it, and you can generate buildings by passing that data. Generate buildings is one complicated code. It has been open sourced. I put the link to Tiago's GitHub repository in the first page where we had his picture. Okay, I guess this concludes my talk. Yep, I hand it over back to Sasha.
Thank you, Rahul. All right, so if you want to get a lot more detail about the things that Rahul talked about, he taught, together with Jason Kunkel, taught a class at AU titled Getting Started in Design Automation, Revit Forge, or Revit on Forge. So that is a really cool class because it actually goes into a lot more detail about what Rahul talked about here. There are a bunch of other classes that were recorded as well. So if you are looking for a little bit of inspiration, you can get some. A number of examples are actually things that we covered in this talk. So some of these videos are shown here. So definitely check these out and make sure, most AU sessions are recorded. So that's really the powerful thing about AU is we can make that available to you even if you are able to attend. And if you are interested in really getting your hands dirty, we really encourage Forge accelerators if it's not something you're familiar with. It is essentially a week-long hackathon where you show up at either an Autodesk office or another location, and you work really, really closely with the Forge partner development team and occasionally people from product to make sure that you can actually make your idea into a working prototype by the end of the week. So 1 week, you walk away with something that's working on top of Design Automation API or a combination of other Forge APIs as well. I've listed a bunch of dates coming up. So as you can see, we hold these around the world. If you are interested in working directly with the Design Automation for Revit team, I highly recommend the Boston Accelerator because that is where our team is located. So that's an opportunity to work directly with us and talk about the things that you're trying to achieve. With that, that actually brings us to the end of our talk. So please feel free to enter questions and we'll go ahead and look to answer them.
We have a bunch of questions, but before that, I have a question which I need to relay to you. So can Design Automation for Revit connect to SQL Oracle database? Can it updates the content of an SQL database?
Rahul, do you want to take this one? I can take a first pass. Not directly, again, because we can't dynamically communicate to a database. So you'd have to create an intermediate file format to be able to transfer that information.
Okay. Yeah.
Yeah. Sorry, okay. Go ahead.
Yeah. Okay. Thank you. And there are other 14 questions. Probably it's easy to read instead of me.
Yeah, sure. I'll go ahead and read them. Let's see. The first question that I see on here is there an example for clash detection using the Design Automation API? Currently, there is not. This is more of an idea of something that you can do, but I am not aware of an example at this point. What programming languages do you need to know to start and build whatever we want? Please provide a path to start. Rahul, you want to take that one?
Yeah, we did provide the path To start, I would recommend using the Postman samples to first use that, and then slowly graduate into using the samples, that code samples we have. A programming language for getting started, I guess we support multiple. There are C# SDKs. There is also well, JavaScript is universal in calling design automation APIs, so I would use that too. I believe there is a Node.js NPM package available for calling design automation APIs as well. So, yep.
Thank you. So next question. Yeah. Next question is, which companies are using this product applied to real projects? So hopefully this question looks like might have been asked before we got into the examples, but hopefully you saw a bunch of the videos. So those are actual real companies using it on real projects or soon to be real projects. We were in beta until recently, so we did ask people not to use it in production. So I'm really, really excited to see people starting to approach this from a production perspective now that we are launched. So the next question is, if there is no connection to the network, the connection to a network database cannot be performed through Design API, but the data has to be read by another app, which in turn will connect to the database. Is that correct? The answer is yes. I think what we talked about is you can't connect directly to a database, but you can write it into an intermediate file format, and the secondary application would actually have to write it to the database. So the next question is, do you need a BIM 360 license in order to use the data in Forge? I believe you do not, in order to use it as a third party, I believe you just have to be entitled to be able to access that data by whoever owns the account. I do not believe you need a license unless there are permissions, limitations. One of the things that we're actually thinking about is how do we make sure that we protect Revit Cloud work sharing data, so that currently you only need two-factor authentication to do Design Automation API. It's quite likely that once we start supporting BIM 360 models, we'll actually be supporting three-factor authentication to make sure that people are have proper permissions. At that point, the people who have need permissions to those models would need a license in order to be able to access those models specifically. But in general, to BIM 360, I do not believe you need a license right now. Another question, why is there nothing for Robot and Navisworks? So I think that's a great question to ask to those product teams. That was just not something that was initially identified as the top priority, but there's nothing preventing us from putting Robot or Navisworks into this kind of engine going forward. Can I provide an estimate of when opening a live Revit Cloud Cloud work sharing model will be available? Unfortunately, I can't, largely because we haven't actually figured out the technical details of it, which means that given that we don't have a technical solution yet, it's really hard to provide an estimate. It's not going to be in the next few months, I can tell you that. It's because it is actually a pretty complicated problem, so it'll take us a while to solve it. Would it be possible to import a Revit 2020 version file, make some design automation tasks, but save the output file in Revit 2019 or 2018? Unfortunately, you're restricted by the same file format that you are now today. So there is no backwards compatibility in Revit. Design automation doesn't really change that, largely because that would mean a loss of data. If you guys are curious why we're not looking at backwards compatibility, there is a Revit ideas request that I wrote a fairly lengthy reply on, so take a look at that. That hopefully will answer why it's actually a big challenge and why backwards compatibility is not something that we're making a huge effort for. Link to the videos, please. I am unfortunately not going to be able to most likely provide direct links to the videos. They'll have to be part of this presentation because I don't think we have permissions to share the videos, but we will do our best to make sure that the videos are visible when we post this to you guys. So how soon after Revit 21 is released should we expect the corresponding design automation engine to be available? This is not a commitment, but this is something that we typically look to time at about the same time. So things happen, I can't guarantee that, but there is really nothing that prevents us from being able to do it in a short period of time. Let's see, is the Revit core console.exe also part of the Revit standalone application local installation, or is it Forge only? It is Forge only. Unfortunately, it's not something that we can make available locally for a number of legal reasons. So how do we configure the use of plugins for different versions of Revit 2018, 2019, and 2020? Rahul, correct me if I'm wrong. I believe the specification of an engine is part of the, is it the activity or the app bundle?
App bundle.
App bundle. Okay, yeah. So when your app bundle contains your add-in code. So when you specify an app bundle, you would actually specify the version, the engine that you would like to use. So you will have to create different app bundles for each version of Revit.
And I would like to add that we do have the backward compatibility support, just like your desktop Revit add-in for 2018 would work on 2019 and 2020. Similar design or similarly design automation app bundle, but you could just run the same one. The add-in that you built on 2018 will also work on 2019 and 2020.
Assuming you're not affected by any backwards changes or backward, because we do have breaking changes every year. So
that is correct.
Yeah, but the restriction is the same on the desktop as the cloud. So if it works on the desktop, then you're good in terms of. Can output files be posted directly in third-party clouds such as Dropbox or OneDrive? Yes, absolutely. Like we said, we don't really care where you post it. You just tell us where you want us to put it. That is where we will put your data. So it looks like there's a comment where can we get all this info from? So I'm not quite sure what that is referring to, but there's lots of documentation, lots of samples. So hopefully those are enough to get you started. If not, please do reach out to the Forge Partner Development Team because they can really help you get up and running. Will there be an online broadcast for Forge accelerators? So I believe, Vero, is that something you can answer? I don't think it's not something we broadcast, but any kind of comment there?
Yeah, Forge Accelerator is not like a session which can be broadcasted. It's more of hands-on. So it's basically a workshop where you sit with the FPD team and program your own task. So I don't think that suits the broadcasting kind of scenario. I hope I answered the question.
Okay, looks like there's a few posts in here along the lines of specific exceptions. I recommend filing a case with ADN if you're having specific problems. There's a comment that says the DLL must be from .NET. Yes, because this is the Revit API. That means that yes, you need to know a .NET language and you do need to write the add-in in .NET. Let's see, with the last example, you provided a URL for the map data. It is easy enough to handle login if required. For example, if you need to log into OSM to download the data. Rahul, you want to take that one?
Okay, you provided a URL for the map data. It is easy. So you need to log into OSM to download it. That's as long as design automation only cares what the URL you provide has to be a single URL. That is, it's got to be a download URL. It finally calls that URL and the data is downloaded. If it requires login, it means that design automation probably does not have the permission to call that URL, so it won't work. But I believe OSM API might have some way of getting authentication into the caller, so you'd have to provide that.
Okay, thank you, Rahul. Right, so next, can you repost the GitHub repository link? So I believe anything that we referenced that has an Autodesk origin is available as links from the Forge documentation. So you can Google that real quickly. We can certainly post it as well. There was also one other GitHub, I believe, from Blackboard, which we can certainly post going forward. Or maybe, Rahul, maybe you can answer that one if you can pull that.
I'll post that right here, right now in that answer section.
Thank you. Another question was, have there been plans to create a feature that can convert Revit into GeoJSON files? Nothing that we've had a conversation about specifically, but there is nothing preventing you from writing your own add-in that does that if you know how to create GeoJSON files. Is there a unit testing framework or library? I don't believe we actually provide any kind of unit testing, correct, Rahul?
Sorry, I got distracted. Is there a unit testing framework or library? Nope. There is no framework, but there is some documentation on how to handle local debugging. If that's what you're looking for, there is no unit testing framework or any. There is an SDK, but that's only to make the API calls. So those SDK libraries are there for .NET APIs as well as JavaScript.
So if I have a large Revit model and run a simple design automation script, do I have to download the entire updated model from scratch, or can I get just the updates for the Forge viewer? You are able to create updates from a Revit model for the Forge viewer. So we've actually had some examples of people augmenting the Forge viewer deliverables using Design Automation API. However, Design Automation will need to download your entire model in order for you to extract information from it. There's another comment in here that's saying that processing time starts when you download the file or start opening or when the file is open. Processing time includes download and upload time. So when you start download is when we start counting Forge Cloud credits. Is there another question? Is there any specific material we can prepare before we join the Forge Accelerator? So the Forge Accelerator is actually an application program. So you would submit an application with a proposal to the Forge team. They review those applications and then you are invited to join if they think that your application is actually something that's buildable. So that's one of the key things. We want to make sure that we work with you to identify something that you can actually build in a week so that we're addressing a reasonable scope. In terms of preparations, I would say the first step is that application. Once you're accepted, you'll get more information from the Forge team about how, things that you can do to prepare. But for the most part, bring a laptop, yourself, ideas, and read the documentation. Let's see. Anything will come to support connections between Tekla and Revit. Nothing planned directly for design automation, but if you've seen the Revit public roadmap, we do talk a little bit about connections to Tekla and Revit there. So things that end up happening in Revit a lot of the time will likely end up as part of design automation in the future as well. Again, no promises there, but it is a conversation that the structure team has been having. Another question is there or will there be a European server in the near future regarding the upload and progress time? As of right now, we do not have plans for a European server. While we're looking to get to scale in the US to prove that this is actually a service that we can run. At that point, we'll, like we always do, evaluate and determine whether we want to spin up a secondary server. Why don't we have a LinkedIn page? That is a great question. I'd like to know what you would want to see on such a LinkedIn page. So typically, Autodesk products don't have LinkedIn pages, so that's not even something I thought about. I'd be curious why you'd like to for us to have one. So let me know. And that is the answer. Sorry, that is the list of questions we have so far. Anything else? Looks like there might be. Oh, it's a great way to share with professionals. Yes, it is a great way to share with professionals. Feel free to follow myself or Rahul on LinkedIn because we will post stuff there directly. So typically, by the way, other sources of information, if you want to follow updates, there is the Forge blog. So that is where all of design automation updates happen. Another great blog to follow is the Revit blog. So between those two, we typically cover design automation and kind of any notifications that you can get from us. Question, will Autodesk move from AWS to Azure? As of right now, I am not aware of any plans of migrating off of AWS. Okay, counting to 5. 1, 2, 3, 4, 5. Looks like we are all set with questions. Thank you very much, everybody. We really appreciate your time. I hope you learned something useful today. Take care. Goodbye.
Thank you. We will be stopping the recording now.